Yeah. There you go. Sleep at the wheel.
Morning.
Morning. Yeah, coding furiously, of course, and lose all track of time.
Hey,
Happens to the best of us. Worst, something. Yeah, just like snoozing away. Boom, 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 boom. I'll have to sort people out in a minute here. Who else?
do we have a Google Docs?
Sorry, say again?
Do we have a Google Docs?
No, that's a good answer. Let me go do that. Yeah, furiously coding. Yes. Change. Everyone can edit. Done. Chat. Where'd the chat screen go? Boom. Okay, there's our Google Docs link.
Happy Friday, everybody.
Yeah. Somebody else tested. I see people logging in. Okay, somebody else. Yeah, some people are trying to get in. Hey, I can't join the meeting. Well, that's because, you know, I'm asleep. So fine. One more maintenance here, and then I think I'm good to go.
I'm briefly logging in another device to get a Google Doc, so I don't have to bother you. So,
How far past the hour did we start the recording?
About 7 minutes, 5 to 7 minutes after. I think probably 5. I'm in 2 minutes of like trying to do maintenance here. Said I'm slow to the party. I'm playing catch up. Almost got it. Except new people keep showing up here.
can someone send the doc to the chat again, please?
There it goes.
Hey, Cliff,
May have caught everybody.
for the next one, Cliff, you should start the doc before you send your email, and then you can put the link for the doc in the email.
That would require me to have thinking and brain cells and stuff, you know. The process is getting refined gradually. Sounds like a great idea. Okay, so since we're all here, and I'll play more catch up later, let me just do the spiel. Okay, this is Coffee Compiler Club. Welcome. Sorry for the late start. Free open conversation about compilers and language runtimes and garbage collections and typing systems and concurrency and syntax errors and I don't know what all. SSA form. I got a request to do SSA form. I reserve the right to moderate, never had to do it. You're being recorded live. Given that the new timing things show up in the Google Docs, the video goes out pretty quick. Thank you very much. I think it's Theodore. Are you the guy doing the numbers there? Yeah, thank you very much for that. That makes a big difference in my life.
No problem.
Removes me from having to review a 2-hour meeting a second time to find exactly that stuff that you're putting in the timing. That's it. That's my spiel. You know, we're good to go. I think we have some new people here, like Jim Northrup.
Hey, yes.
Yeah.
I'm. I can't give video, but yeah, happy to be here.
Can you give us like 10 seconds of what you're doing in life? You know.
Okay, so I live in Bali. I'm sort of semi-retired and, you know, working on various semi-retiree kind of projects. So AA looks like a very fun place to examine what might be to me a way to bring the STL back to life in something modern besides C++. So that is it's the main gist of my involvement so far.
Exciting. Yeah, I'm in the semi-retired zone too, and I'll give you fair warning that AA has no execution engine right now. I'm sorting out typing, and the syntax is still flexible. I know that was you were excited about syntax earlier. Because the STL was looking for DSLs, right? Is that what's the email you shared?
So something like that. Yeah, so I use Kotlin because it is thus far a friendly language for doing these cells. Sorry. So what else? It's got a lot of convenient features, which among them exclude JVM performance. So, they've got their LLVM, head start, which they have abandoned and gone with an IR direct compilation model. Yeah, last week I came up with the idea, why was LLVM putting the graph in IR? Well, because that was like 20 years ago. It seems like processing RAM and modern paradigms and maybe cool typing might be able to support an environment that does not necessarily segregate the IR level graph and compilation mediums from the compilation and perhaps the IntelliJ level of PSI interpretation. And if you had something like a graph instead of a syntax, you could put everything in the graph and focus on the syntax as a secondary. And I don't think there's any pain other than, the graph is what it is.
Have you looked at any Sea of Nodes compiler?
No, but I'm happy to start exploring. I'm not
AA
familiar.
is Sea of Nodes compiler, more or less. The syntax goes straight to Sea of Nodes. And then the question that
Would
I've
you
been
like to
asked
define the
before
term
is-
first, Cliff?
I'm sorry?
Do you want to define the term Sea of Nodes?
Oh, yeah, fine. SSA form, not minimal SSA, but SSA form, and also all your control flow is in the same graph. So it's a single unified graph that holds data flow and control flow. Which means, for instance, that you have def use and typically use def edges everywhere directly. That is the IR. And that's the IR that's in the hotspot jet. Other things that come out of this that are not obvious follow-ons are you typically optimize by doing graph rewrite rules, which can be provably shown to give you sort of the optimal answer for the standard conditional constant propagation kind of things. And then for the other side of the world where you do global value numbering versus PRE, it clearly handily beats PRE, and the graph rewrite rules are typically pretty trivial and lead to very fast optimizers, which, that's C2 in hotspot. All your classic compiler optimizations fall out of the Sea of Nodes as graph rewrite rules sort of directly. The only thing that doesn't fall out directly is loops. Everything else falls out very directly and very efficiently. So provably linear time for the best possible result of all possible linear compiler IR optimizations done in one pass, up to not including loops. And I guess inlining you still make calls on, but you can inline incrementally and get the same kind of behaviors out of it. So anyhow, it's a very fast optimizer, very simple once you get your head wrapped around doing graph IR rewrite rules, as opposed to sort of a control flow graph with basic blocks and tuples in it. So it's a different story. Aliasing information I store by claiming memory is broken up into equivalence classes according to your alias relationship. Because it's equivalence classes, it can be directly represented in the graph IR. Because it's directly in the graph IR, you don't have a separate alias pass or alias information kept anywhere. The graph is also your aliasing information and does all your alias optimizations just as normal graph rewrite rules. And again, this is in C2, been used by the Java compiler for the last 20, 25 years. So it works out really well. Is that a good definition for C of nodes? I missed something?
It matches my pragmatic impression of, turning on the inliner logging and seeing what happens. That's,
Okay, fine.
I had the Dragon book a long, long time ago, but somebody walked away with it before I got to read it. So
There you go.
that's my deficiency there.
It's not terribly hugely related to the Dragon book. I can give you like a one-to-one mapping between the Dragon book's IRs and Sea of Nodes, but you got to wrap your head around a graph as opposed to basic blocks with tuples in it. And once you do that, the Dragon book doesn't help a whole lot. Yeah. So I'm not.
So my
Dragon book's
impression
all-
with LLVM. My impression with LLVM is that there is, IR is a graph. It's just a syntax
Yeah.
specific to typing.
Yeah.
It's got some cool features,
It's a very
multi-bit
different graph.
lengths.
Yeah, it's a very different graph and it has very different semantic overheads. I'll claim the Sea of Nodes has one big byte to understand it, and then it's hell of a lot simpler than LLVM and faster. But your miles may vary. We need to get Arthur in here. He's not here today. We had an LLVM fan in here who's hard at work making it work on Java bytecodes. And he has a better impression actually about LLVM than I do. So I shouldn't lambast that. I'm not a bias. I'm not an unbiased observer.
I'm only using it as the more sane of the two examples between what is GCC using, Gimple and LLVM.
Yeah.
It seems like everybody these days sort of, I don't know, every new thing that I see is like, I get excited about it. And then it's like, oh yeah, we're just a front end for LLVM. And I'm
Yes,
like, oh, come on. Like, I know that like all the optimizing passes are written really well in there, but like, I want something that's like, when I get excited about something new, I want it to be new.
There's two
Well,
big choices.
what's the unique proposition though of spitting out, different instruction sets? Like, if it's done once, it's done once. If it's done
I know,
once
and if it's done well, you're right.
Right.
You're right.
right.
So the
But it
difference
hasn't
here-
been done. It hasn't been done well. But
That's
LLVM's the closest we got.
exactly. So the one in Java is done well and it's hard to get to, and the one in
Right.
LLVM
It's not general purpose.
Yes.
The one in Java is for Java.
it's
The one in
not, but
LLVM
it's pretty close. The Java wrappers around it hide that from you, but C2 doesn't give a flying fuck about.
Right. And then
what it
there's
is.
another problem as well.
It's buried. So it's buried inside the JVM.
No, it's license, right?
Oh, that's true too. I
So-
don't know about OpenJDK. Is that?
The license for it though is viral.
It's GPL.
It's a feature, not a bug.
Yeah, exactly. There you
Yeah,
go. Well,
We
AA has a
found out
patchy.
about Stallman's
so-
features. We don't need any more.
I'm of the opinion that I want to get a C2 level optimizer that's pried out from under Oracle's thumb. So
Well, I mean, I didn't want to get into the details of the emitters so much as the idea that we have multiple different syntaxes for variable declaration in Java for multiple, modes of scope. We have annotations that are completely unrelated and patched on the back. And then we have generics, which are, causing cognitive dissonance for me. So are you, that brings me to a really brief question. Is HM essentially bringing Haskell types, without the Haskell rhetoric in your mathematical paper that you pushed into the docs directory, your PDF?
Yeah.
A taxonomical accounting is easier for me, having more of a semantic background than mathematical. Pragmatic coding anyways, so, okay, so HM is essentially the Erlang type system.
You asking about AA's type system?
Yeah, well,
Yeah,
HM.
HM is my one file exploration of merging a forward flow typing system as you find in C or Java or Fortran with Hindley Milner style, which is what you find in Haskell or OCaml or ML, Standard ML, New Jersey, and that kind of stuff. So the HM file sets in the AA code base are just research prototypes. They have a bunch of test cases associated that demonstrate doing exciting things with a merged type system. That's my intention of bringing that over to AA. That's in mid progress right now. Like I think I have the type system more or less sorted out, and I'm trying to get it going in AA.
So what excites me is that you can express this graph without first defining the language in concrete terms, where if you can get the graph expressed correctly, you can come back and figure out the language syntax later. In theory, that seems like a sound principle to me. You just have one syntax for the graph, the state of the graph being compiled, and then, you know, it would be a quirky thing, but then you have, you know, a delta of a delta of a delta, which could be expressed somehow, perhaps a couple tuples at a time, until you have the culmination of the environment, the externals, the, you know, local, and the, you know, the determinants.
AA is a collection of pieces here. You're talking about sort of separable pieces. There's a graph IR internally, which represents program semantics, and would have the typing system I'm talking about. So Hindley Milner plus forward flow typing. There's a way to get a graph built using some concrete syntax. I could have picked Kotlin or Java syntax. I did not. I picked AA syntax. But you have to have a syntax to go from a text file to a graph.
Well, you know, in my head, like I'm imagining, you know, graph viz dot, for instance, is a graph notation. You know, it's semi compact. And then my suggestion was to go with full dump format as a programming language enablement on top of whatever else falls out.
So people have screwed around with direct graph implementations, and the usual story is that they're really hard to work with mechanically because it's just too like graph viz. Graph viz doesn't let you edit a graph. It gives you some kind of visualization, which works great for small graphs and sucks for large graphs. It's not how programmers' heads work very well. It's a nice debugging tool for the compiler's IR internally, but not necessarily the best or the only debugging tool. It's not a programming environment. The ability to dump into an internal in computer memory graph into a graph viz format, dot or whatever the hell you're going to be, and then you display it, then you edit and you want to inhale, then you have another kind of a syntax that you're inhaling from a text file to turn into a graph IR, which is the nodes and edges format and the dot format, which just graphs with nodes and edges and annotations to describe things.
That is essentially what your parser is going to do for you by parsing the next line.
No, we're missing.
Is it not?
Maybe we're missing a piece here. The piece that's missing here is that you have a different syntax which reads a graph as described by nodes and edges in the dot, which is a JSON format that's inhaled by graph viz. And then you manually edit
not
it.
Specific to dot, but yeah, dot is, I'm throwing it out there.
Yeah, right. So I'm saying that you're coming up with syntaxes that you want to inhale and produce a graph, which is great. That syntax is very hard to work with manually. It might work well as a programmer toolkit tool where you have a program that wants to take a graph that a human wrote using, say, AA, and then manipulate it because they're doing dependency injection of some kind. And so they dump it out to a graph viz format run a separate pass that doesn't understand lexical parsing syntax at all, but just reads the graph to graph, does a semantically correct transformation, adding dependencies or whatever, and then rebarfs out a graph in dot format, and then you inhale that back into your execution engine at some point. I mean, is that what I'm hearing? You're looking for a way to write a
Essentially,
tool that runs over.
yeah, all right. So, I mean,
graph.
you could retrofit this into Java by, overriding annotation to be, a wicked complete graph system on top of the Java language. But, the Java annotations is, the focal point of my gripe is that, it's a random add-on, just like generics
right.
are a random add-on.
Oh, wait, it's worse. As a random add-on, it has no information the JVM internally can use. You have to assume that it's hacked by every hacker to be the most evil thing possible. Then adversary is maximally evilizing the annotations. So
if your annotations are a blackboard, I mean, if they are literally a blackboard that's got no future evolution in the dump format, then
right,
it's a handy thing to have in IntelliJ, at least, to say this is absolutely the type, and this is absolutely the modifiers of the type and the modifiers of the scope that I want.
But it has no program semantics.
I can tweak it
that the JVM can trust.
So
the JVM, when execution time comes, they are stripped out.
I agree with that. I mean, being able
what do you have
to.
against with being able to put strings on things?
Yeah, right. I'm hoping to have a user extensible type system that has, a lot of the things that annotations get used for.
Have you ever played that PlayStation game where you, it's like a virtual world and you go around and you've got the little sock puppet guys?
Animal Farm?
No, it's a different one. Weird Planet, Cool Planet, Amazing Planet. I don't know. Anyway, one of the things you can do is like
Planet.
Little Big Planet. Thank you, York. You can tell how much of a gamer I am. So you can put tags on things. So my kids are really annoying. They expand the size of the tag to be bigger than the screen and then put them on everything so you can't see anything. So that's annotations.
Yeah. First thing you do is just strip them out so you can see what's going on. Okay, fine. I think I got the analogy here.
They're non-functional. They're just for looking at.
Yeah, I'm in favor, actually. So if you had RDF specifically, you could actually do Sparkle reasoning about your graph. Define RDF. Resource definition format. This is you might see the Wikipedia dumps. Those are giant tuple dumps in RDF formats, plural. There's turtle, there's
It's XML based. It's XML based, right?
Well, it tends to be used more as a triple store than as a sort of XML nested document. But
or a
same
triplet,
idea.
yeah.
It's called first order predicate logic. XML is a little bit low entropy for that. But the n triples is a dump. It's it only has one line format. So subject, predicate, object is every single tuple, and that's the extent of the RDF graph. So you can reason with this forward predicate logic about the graph using Sparkle, which is very mature. The format tools to parse and regurgitate and mix and join RDF is also extremely mature.
So Jim,
yes.
Question for you. I mean, this is still on the annotations, right, that you're describing?
Essentially, it's like a hyperspace for if I don't want to program in a syntax, I can just define the graph. And I can ask the editor to call up the current graph.
Right. So tell me what you would want an annotation to do. Give us an example that we can work with.
I would want to, instead of say debug this, put a little debugger on the point and then run it and see it in the debugger. I think that there is a benefit to, right-clicking during your IntelliJ editing session and seeing the graph of all the types, all the scope modifiers, all the, the
Isn't that
funnel
information
leading to
available?
that point.
Isn't that information available right now in IntelliJ? I'm getting.
There is a PSI graph parser of the Java or the Kotlin language. And the same thing with this Visual Studio code server thing. There's, some kind of ultimate regex providing context and refactoring capable languages, numbering, I think, greater than IntelliJ now. But the RDF would be a single, hyperspace annotation that has no future evolution path. It will be as.
I'm sorry, I'm missing now why. What I'm hearing you say is replace annotations with some other format, which is being described as a first order predicate logic. And I'm missing.
Jim, you aren't mute if you're talking.
He's not muted, and I don't have any sound. All right, so he's in Bali. He might have lost internet. Darn it. Hey Jim, you're silent on our side. I think you lost audio output.
I'm telling you, that Starlink is not ready for prime time.
Wow. So as a
Will Hawkins had a question. By the way.
just a second for Hawkins here. For Jim, if you can hear me, as a fix, you might try to drop and rejoin. We have a couple guys overseas who drop and rejoin periodically to get their sound reset. And I will throw that in the chat. I see that here. And then let's get it, yeah. Will, what were you asking? Oh, PO course.
Yeah, I didn't want to interrupt. If there was ever a quiet moment in a lull in the conversation, I figured I'd throw that out there. So.
I'm
You want to say your question out loud for the people watching online?
Oh, sure.
Later?
Yeah. I'm sorry. Absolutely, Aaron. Thank you. So I'm going to read back the chat just so no one thinks I'm hijacking the conversation. I said, for a time when there was a break in the conversation, I was wondering what the group thinks about this. I'm teaching a PL course, and I was wondering which of the semantics, operational, axiomatic, or denotational, to teach.
And I'll claim that I'm terrible with denotational and I should be better, and I'm all about operational semantics.
Yeah,
so since I'm not a computer science major, can you tell me what those words mean?
Sure, of course, absolutely. Well, I am a computer science major, and someone's going to have to tell me what those words mean. So the idea with operational semantics is it's a formalized notion of how an idealized virtual machine would operate when your language is interpreted. Axiomatic is a way to use logical buildup to go from the end state of your program back to the leaves of your program in the tree, back up to a fundamental. Coke. Say again.
Sounds like Coke.
Yes, it's very, yes, that's exactly, yes. And a denotational is, the way I think of denotational is the denotation, it denotes, your program denotes mathematical operations. So your program is always in a state that's encapsulated by a mathematical function. And each of the operations is a mathematical function that transforms that mathematical function to another state.
One of the things.
Did I mess up anywhere? Because this is recorded and my students are going to probably hound me if I got it wrong.
That's about right.
That sounds good to me, yeah.
Thanks. Okay, good.
So you can think of the JVM's underlying bytecode execution model as an operational semantics.
Yep, that's exactly right.
And the JIT is just an optimization, and the interpreter is just an implementation of one of many, and there are many different interpreters for JVM bytecodes. But the semantics that you get out of the JVM, whatever documentations describes the execution for the interpreter, that's operational semantics.
And I think that's why ultimately what I kind of want them to be able to do is to translate the semantics that I teach them into implementing a little interpreter. Yeah. So I think OpSem is probably the way to go, because that's sort of, but I just didn't know if anybody else had any.
Well, I've been fighting with reading papers on how Hindley Milner and its extensions work, and they're all done with denotational semantics. It's such a large jump from denotational to something you can do something with, you can implement, that it's just a pain in the neck.
Yeah.
You read these people, we have an algorithm and it's described in denotational semantics. There's no algorithm in sight.
Yeah.
There's a series of rules.
Most of the
Fine.
most of the extensions, it's real hard to implement it into the real functionality because there is no code. Here's some ideas, here's some formulas, and you're
you
at.
got a paragraph of thick text followed by a Unicode random character emitter followed by a paragraph of thick text. It's like, goodness gracious, people. And then you got 6 pages of references at the bottom.
Yeah.
And as my programming language professor said when I was in grad school, PL researchers have math envy, so they like to make Greek symbols everywhere. And you're like, that's just totally unnecessary. But so the other question, so I was actually watching a talk by Eric Meyer about doing denotational semantics, and it was pretty interesting. And I liked, I mean, I think it's fine, but yeah, I agree with you. It's, I think operational, and Theodore, I was going to ask you a question right when you were talking. I was like, man, I want to jump off your point and ask you a question. And now of course, totally escapes me. So I'm sorry, but you were making a very good point.
It'll come around again.
That's right.
Yeah.
Yeah. Thank you for indulging my question, everybody. I appreciate that.
But when it comes to denoting what something does, I think it is a useful exercise in a programming language course to take an excerpt paragraph from the C++ spec and ask the entire audience to debate, what do you think this means? And what should the program do?
It's exactly, that's a very,
and that will very much teach your people why there is always going to be some undefined behavior that your specs cannot actually specify perfectly. At some point, you just have to get out of the compiler and see what it does.
Yep.
Yeah.
Thank you,
Yeah.
Aaron. That's a great point. Thank you very much.
It's fun to watch. There's some good articles. I read them even recently. I should find them. It was describing a bunch of the places where you have undefined behavior in C++. Here's what the spec says. Here's what a legit optimizer can do. And as soon as you have said, I assert an illegal cast because I can do that in C++, a good optimizer on the following machine can take the following hacks. They're totally legit, and here's why they're legit. And suddenly you are just screwed. And it's so evil to look at that going around saying, oh God.
I did that. I'm trying to teach scope and storage lifetime storage bindings today in class. Yeah. And I was returning pointers from scopes that got destroyed. And they're like, well, what happens then? Doesn't that work? And I was like, it might. And it could also burn your house down.
Yes.
So to be fair though, C++ has gotten slightly better in the past 10 years at this, because the old C++, you know, the one that I was forced to work in, you know, there was nothing defined. I mean, it was just an undefined, like, every vendor's
way
compiler.
to write machine code in a high-level language.
Right. So we used it as C with better macros, basically.
Yeah, right. That's what we did.
Well, better macros and worse error messages. I mean, that's what C++ was.
Once we got past C front as the front end, we got the error messages back to being reasonable.
But then Herb got involved and it started getting cleaner. Right.
Yeah,
so like the specs actually make sense now, and 99% of what Yarn created in the 90s only exists for backwards compatibility. So it's like C++ is, you know, there's BH and after Herb, right? There's and Yarn.
Yep. And I think that like that's the challenge. The other course I'm teaching is Intro to Programming in C++, and that's the challenge for me is like to
use sanitizers. Remember, first lecture, the first thing you introduce before you talk about hello world, before you talk about anything, before you talk about include, talk about f sanitize equals address comma undefined. This is the 0th lesson.
Agreed. Great.
Yeah, very loud, Matt.
Yeah.
Yeah, microphone is.
He wanted to make a point.
Oh, thank you. Is it better now?
Yes.
Yes.
Thank you.
And thanks, Yorick. I know. I wish I could install Rust and have them do it. Thanks.
Yeah. I get it. Well, my kid learned C just recently. This last 2 semesters we've been doing C courses, and he gets it, and he's pretty good at it. It's kind of fun.
The problem for me is that C is my favorite language of all time. I know that makes me an old soul, but I really love C. So.
Yeah, I'm curious to see if we get intro to computer science classes using Rust so that people learn concepts like ownership very quickly. Because if you start with C++, you can get pretty far into C++ before you realize how badly not paying attention to ownership will bite you.
Yeah, that's fair. Yeah.
I can't even get our department to even talk about doing Python. So we're years from Rust.
Really? It's like those are the 2 big options for all the universities around here. Students either learn C or Python, I want to say. Some guys pushed Java, but they were definitely a minority.
Yeah.
Yeah.
Yeah, I mean,
Python's
Rust
kind of
is,
closer to the metal.
Rust is a cool language in that having coded in C and C++, every time I look at Rust, it kind of teaches me something about C++ as a side effect, right? There's a,
Yeah.
Because 99% of Rust's design is to kind of show how C++ should have been done.
Yeah.
Well, they wanted to make it possible to write a browser. And if the thing that your application does is take arbitrary code from the internet and execute it as fast as possible, you kind of want a language that helps you stay away from the sharp edges.
They stress on the safety too. This is their card, the safety card.
Yeah. What is this paper? I don't know what paper I had in mind.
I just wanted to add the
maybe
the reason I went with Java in like 1995 was because reflection was a whole lot better than doing it with macros in C++. For better or worse, that was a hell of a advantage at the time for the purposes.
And of course, you know, all many of the language academics don't consider Java reflection to be reflection, but
yeah. I've kind of like reflection for AA. I'm kind of thinking I'm just going to have eval, and anything you can write in an eval, you can get a query out that asks questions, including it didn't parse because I don't have the following fields, or I do, or whatever. There's probably something else that has to happen there reasonably, but seems plausible that a runtime version of the parser will get you nearly everything you get out of reflection.
Have you thought about the semantics of your runtime type check?
For what?
I want to know, is this thing an instance of this type?
Oh, instance of tests. Yeah, no, I haven't, but the Java version of instance of tests covers like the 99% case in 1 clock cycle. So I'm headed for doing it that way because it's efficient and does an instance of ISA. You're asking, is it ISA? Is that what you're?
Yeah, what the semantics of an ISA should be.
What is semantics or implementations? So semantics are going to be, yeah.
So like if I have the number 3,
yeah,
it is an int64. It also is an int8.
Yeah.
But if I say type, give me the type of this thing. Should it say int8? Should it say int64? Should it say this is
3?
That would require type information.
I hate this design. Come on.
Type of 3 is 3. Yeah, type of 3 is 3. Cameron's in a different ball game altogether. So you know, this gets into what is the user expressible type? It's whatever I can get out of the type system. I can certainly get out of the type system that all singleton integer constants are a type. So the type of 3 is 3.
Well, you know, 25 years later, I would say it's reasonable to declare, I want reflection now in this section, but I don't want reflection on everything, in order to make your DSLs that much more convenient.
Why would you, so Jim, why would you, what's the benefit of doing that?
Like,
Did we lose?
Oh,
we lose
overlay logic, bring in libraries that are yet to be defined, and reflection, gives you a little bit of a, convenience, rather than, programming a little scripted thing to call class by name, class for name. Declaring reflection for certain
Yeah,
delegation
class for name
is
definitely
reasonable.
class for name is definitely a hack, but the concept, I was trying to figure out why you'd want it on some things but not others.
For modularity, explicit modularity at library levels.
so you can't say somebody else cannot use reflection. That's not reasonable. You can choose not to use it yourself. Am I missing?
So reflection tends to give you much more complicated security surface area, where you're like, oh, I have this closure that's protecting some secret. So you can call encrypt or decrypt on my encryptor, but you're not allowed to say, oh, let me reflect on this and pull the key out.
That's a modularity.
That's a design flaw.
Yeah, right. That's a
you don't
modularity
limit
issue. If I define a module and I have a public interface and it has private parts, you can't see the private parts. And that's reflection will not. So I want to make sure that we're talking about the same thing with reflection with Jim here, because the Java reflection opens up all security doors, right? And so that's not the correct way. It's not any way I would do reflection.
Right. You want your private fields to be vampires that don't have any reflection.
Yeah.
Well, the other thing I'd say is that you want code using the reflection. I mean, regardless of language and runtime and anything else, you want code using reflection to have no ability that doesn't exist with the code not using reflection.
Yes, exactly.
Right? And once you get that design done, everything, the security model's already done, right? So the problem with reflection is that it's a completely different, in a sense, so taking the Java example, it's a completely different runtime. Or in C++, the problem with reflection, and I'm gonna violate every academic rule here, but the problem with reflection in C++ is void star, right? I can cast anything to void star.
Yeah.
I know they try to make it harder now, Matt, you can tell me how I'm wrong, but like as soon as you go void star, you have everything.
Yeah.
Like everything that's.
Well, you go from void star to whatever you want to call it, and then you can undefined behavior, tease out all the bits.
Right, and then with Intel bugs, you can even see, what's on other virtual machines. So not only can you see everything in your own address space, you can indirectly see every other address space. So I mean, it's like.
So in my opinion here, the fine line to draw is I would like to have things like reflection and the ability to cast and make tests and do things, and also to write a garbage collector, which crawls a stack, finds things that are bits, claims them to be pointers, reflects on them or whatever, flips them around, moves them, puts them back. And the question becomes, can you implement a garbage collection? Maybe you can't implement it in yourself because you're not allowed to treat your own pointers as ints and then manipulate, put them back. But can you at least hack somebody else's pointers? Right. Implement a garbage collection language. Can we get rid of C? Can we replace C? Okay. C is used to implement garbage collection. Okay, implement a garbage collector without using C.
Right, but the point of what I was saying is, like, there's some languages you want to be able to implement a garbage collector in, and there are some languages you do not want the users to be able to implement a garbage collector in.
Or at least not on themselves.
And they're both correct approaches, right? Like,
all right, I'm hoping I span a better boundary there, but maybe it can't be done. That would be a sad state of affairs where there's, as a minimum, 2 different languages in the world. One where you have to know what the hell you're doing, and you get to implement operating systems and garbage collectors and multi-threading and whatever, and one where you don't know what you're doing up to some level, and these things are all swept under the rug for you, and you get to go. So somebody drives a car. A lot of folks drive a car. There's not so many people that build cars. And are they always forever in separable domains? They can't ever share anything. Right.
But there are certainly advantages to saying, okay, this part of my program needs to follow rules.
Oh, totally.
In this piece of my program, you cannot malloc.
Yeah.
I'm okay with that one.
I love that idea, but in reality, a language is not a pile of features, right? Like going back to this, what was the word that we were defining earlier? Denotational, right? Denotational, like the parts of a language aren't like random things that you put together because you're like, oh, I like this feature from this language and I like this feature from this. They fit together with purpose. So when you deconstruct the design of a language, it's not like you can just take this feature out and say, oh, I don't need that, right? Like, because when I started Ecstasy, one of the goals, before I even had the name Ecstasy, one of the goals for the design was to be able to do memory management either manually or with automatic garbage collection. And what ends up happening is that you have two different models of so as the things accrete together into a design, like to get these two different things in, they come into a design where everything else already kind of matches, plugs into those concepts. And as you bring these two contradictory concepts into one design, you find that each of them competes with parts of the design that are there to support the other one, right? So not competes is the wrong word, but almost conflicts, right?
Yeah.
So you end up with a language that can't agree with itself, right? And I've never seen a language do a good job with supporting both automatic memory management and non-automatic memory management. I mean,
Swift is trying. There's certainly some issues with it.
I'm not saying it can't be done. I'm just saying it's far beyond my capability to envision.
I'm trying to, I know very little about Swift, but I know they have the value semantics and the reference semantics, and reference semantics allow explicit sharing and malloc and free, and value semantics under the hood secretly use copy on write and reference counting, but might as well use some sort of copy on write and garbage collection.
I'm sure Matt is I think the resident expert on Swift. You there, Matt?
I don't hear him.
Unmuted. Reference counting.
Swift.
Yes, reference counting.
Isn't there like two flavors of things you can do? There's classes and structs, and one is references and one is reference counting with automatic reclamation.
Yeah, I think those classes are reference semantic types, whereas structs are value semantic types.
Right. And then as the classes, are they malloc and free? Or are they garbage collection?
No garbage collection, only reference counting.
So malloc.
Well, you can think of reference counting as a special case of garbage collection, of course, but.
Yeah, okay. Okay, oh, but so the references on the classes are also reference counted.
It's only reference counting.
Okay.
There is no other form of garbage collection.
Well, Jim, your video shows up periodically and then disappears. And your sound's gone. But your video's there.
Yeah, I try to get a small snapshot, so at least I look a little more human
There you go.
on my low bandwidth.
Yeah, looking pretty good now. Someone's on your couch behind you there. I don't know if they know they're on camera. Might
that was the main point.
Yeah. All right, fine. Yes.
All right.
So we were talking about like the coherence of a language that mixes different kind of allocation strategies, and I'm with Cameron that it sounds like a difficult job to do well.
Right.
Someone also. Oh, go ahead.
Well, I was going to say, what ends up happening is if you have those types of conflicting things that kind of come as not first principles, but second principles, if you will, like, so perhaps a language that its primary purpose was to mix garbage collection and reference counting and manual memory management. Like if you started with that as kind of the fundamental core principle that you would be willing to sacrifice everything else to make that part beautiful, you could probably build a language around it. It wouldn't necessarily look like anything we've seen, but I'm sure it's doable because you'd be willing to sacrifice some of those other things that don't fit well, right? And you'd be willing to change their shape in order to fit into that first principle.
So I think here D is one example where it is garbage collected by default, but you can, I believe, annotate functions to disable the garbage collector within that scope. And then you have to allocate things yourself. I think it's been a while since I looked into it, and they were gradually changing the standard library to not depend on garbage collection. But I think the general consensus there was that it's basically not practical, because everything's sort of written with garbage collection being the default, that if you opt out, you end up having to re-implement a significant amount of code anyway.
Right, which kind of reminds me, you know, we've talked about the sync versus async before, and you get some of these languages where if you do something async, everything downstream has to be async, or you can't call it. So it's this, you know, I forget what the term was that someone used. I don't know if it was
Function coloring.
Yeah, coloring, the red. I was going to say red black, but that sounds like a data structure.
Yeah, it does
Yeah, I
seem
think
like
it's a
asynchronous calls are
similar
contagious.
approach. And I think, I don't know if it was, I don't remember if it was Pony or Nim, one of the two. They had a pointer type where you could say, yeah, all pointers of this type are garbage collected, but then everything else is not. I might also be mixing it up with a third language.
I got Pony up.
I don't know, it might have been Nim. And Nim also has, like, I don't know, a bunch of different strategies for managing memory. I think the issue there, it's very much similar to the async versus sync approach, where I think garbage collection as a whole is so invasive that you cannot really, you can introduce it as an addition on top of, say, manual memory management, but I think introducing manual memory management on top of a garbage collected language is far less effective, because everything will be sort of built with garbage collection in mind as the default.
So I'm frequently find myself in a domain where I want to have garbage collection around as the default easy answer, and in hot code I want to do manual management. And I would like to have a language that gave me better support. In the land of Java, I have to do object pooling to get the manual management. It sucks.
Well, in JavaScript, people tend to get away with this with arrays. Normally, you're doing everything in garbage collected land, but if you're doing something that needs to, you allocate a big array of something and give it the memory, and you do all of your manipulation inside your array. And then when you're done with that, you free the whole giant array. Like, do you need arenas in your language if you can allocate an array?
The other thing is, Cliff, that, like, I keep going back to this in every conversation, but like what Hotspot showed us is that, you know, at runtime, with runtime profiling information, the best decisions are likely to be made by the runtime, not the programmer who wrote it years early. Right?
No problem with that. The issue is I don't have the current compiler in C2, and every other compiler on the planet for the last 30 years has not done the obvious transformation you do around loops, where you pool around a loop that's going to have a limited lifetime.
Right, but why not?
Well, how long do I wait until it comes around? There's a 10x speed up to be had here. Like, it's a huge speed up. It's not a small number. It's a big number. How long do I wait for it to come around? So periodically I want to say, damn it, I'm going to go make it happen. And then I make a bunch of objects with a little bit of complicated lifetime, not too bad, but nearly all of them die in the loop. And then I don't want to reallocate them. So I manually put them on a free list and manually pull them off a free list. I can't have a big array that's the size of the trip count of the loop, because the trip counts in the billions and trillions. I have to recycle it per iteration around the loop. So I make optionally 1 to 10 things, and then whatever I made, I put back at the end of the loop, at the end of one iteration, is basically what it does.
But for example, if you had perfect escape analysis, that would be easily optimizable. Am I correct?
It should be optimizable with escape analysis, and I'm just not seeing it happen. Knowing
so
what I know now, I would totally head down that path. If we're in a zone where I had a well-running functioning optimizer already, it's time to go to the next level. I would look for that opportunity. Yeah.
So the concept we have is one we call assumptions, right? Which is like, in the type system, is
I would,
supposed to help.
Don't mean to interrupt. I would very much love to have an assertion of EA, that this will not escape. And this is an error if it does.
Mm-hmm. Yeah, what I'm manually doing is basically that.
At that point, don't you need to have a way to name scopes? And be like, well, am I not escaping this or one stack frame up or 12
No.
stack frames up?
Right. So I start from the scope where I say it doesn't escape. I'm gonna say my pool is outside the scope, and the pool is a global to the scope, and I pass it in, and then you pull from the pool, and then you put back on the pool. But there's a pool which comes at a scope level, and things aren't escaping out of that level. That's how I'm naming the scope.
So my idea with this is assumptions concept is that, as you collect, so it's like you have three numbers, right? 0, 1, and infinity, right? As you collect profiling information, you're looking for the zeros and ones, right?
Yeah.
So, this never happens. This happens exactly once, and this happens n times, right? So 0, 1, and n, right?
Yeah.
And so if you're analyzing escape information and something never has escaped more than 4 frames, for the sake of argument, right? You can say, okay, I'm in a loop, I'm 4 frames deep, never escaped more than 4 frames. So what would make this false? So my assumption is never escapes, but we're in such a, maybe it's dynamic, whatever the reason is for the language. You have to know what triggers the.
I did this work. This was this.
Of course. What do you think inspired this? Come on.
Okay. All right, fine. This is SBA work done at Azul. And it, technically it worked reasonably well.
SBA, I don't know the acronym.
Stack-based allocation.
Oh, yes. Right.
It was
exactly.
escape detection as opposed to escape analysis. And then compiler optimizations based on escape detection. I never got to the point where I did real compiler optimizations other than allocating things with a lifetime where they would recycle. And there were always corner cases that made it difficult. So, the argument can be made, I didn't try hard enough. And the argument could be made, I needed some other piece that I didn't get out of starting from an observation that it didn't typically escape. I couldn't prove it never did. It typically did not.
Right. And that should
But
be.
aren't there a lot of things
right?
that fall into that category of this three-way decision? Compiler can prove this never happens. Compiler can prove this always happens. Insert runtime check.
Well, you end up inserting the runtime check all the time. And that's the whole point you're trying to dodge. Right.
Okay. The other thing is about locality of information, because the same code can be used in 5,000 different places.
And some places,
in one place it's always or never, and in another place it's sometimes and sometimes. And you want to be able to decide based on the hotness of the code when it makes sense to expand the statistical analysis, the collection of information, because you have to rewrite the code to collect more data, right? So when does it make sense to collect more data? When does it make sense to collect more locally, right? So
how would you even express that I want these articles local to each other as as close as they can be, even if they are instantiated relatively far apart?
I would never express that. That's the difference between me and Cliff. Is like I trust people like Cliff to figure that stuff out dynamically, as opposed to writing a language where you have to say it.
This might reduce the pressure to use cuckoo hashes to do this thing, to change the algorithm because the memory behavior.
So there's a lot of things floating around here that I have a fair amount of experience with here. The whole objects are local is one of the things that comes out of a garbage collector, a moving collector, that turns into cache locality and performance. The collector simply walks the live edges and compresses, and you typically get to the second object from the first one by walking a live edge. You don't have to do any sort of analysis of locality references. People have explored it in the literature. No one has a running implementation, but the garbage collector layout does.
I was going to say, Cliff, I don't know if you've seen the DDR5. The spec isn't quite finalized yet for like the DDR5.
Right.
I was reading an article on Samsung's latest 512 gigabyte DIMM. And so they more than doubled the bandwidth, roughly doubled the bandwidth. But the if you look at the latency, first byte latency, it went way up, right? Like tripled almost. And so just as I know it's a non sequitur, but it actually fits in. Like, the reason that they're doing it is because the code that we're running today times the number of cores that we have today can't fit on the bus. So we're killing the bus, right? We got plenty of cores, we got plenty of cycles, and we are just literally saturating plus on the bus. We can't get our code to, and that's what this comes down to. I mean, that Jim, that's really to your point, right? Like, the code has to be written in such a way that it's worth making the code less efficient in the purely academic sense in order to offload traffic from the bus. Because
you're more concrete than that. You said you're on the right track. It's worth making the code burn more CPU cycles to dodge memory cycles, right?
Right, because we used to think that if was expensive, right? Because if would cause a pipeline stall and blah, blah, blah. And now it's like if is running inside the CPU. Like, I can have 50 ifs and that's still faster than one memory access. So if I can figure out how to avoid a memory access, so I have 50 pipeline stalls, but the first one's the only one I pay for. It's like.
So the loop object pooling hacks I'm talking about, the goal is to have the temporary data being used in the loop body live in your L1 cache, right? And it gets you off.
There is a great example in the Java Doug Lie exchanger class. I think there's 12 doubles on the stack for the express purpose of avoiding CPU collisions. And when was the last time anybody has ever used an exchanger to do spin locks? That was like a temporary solution. That's, it's already, there's papers out there saying this is twice as fast as exchanger, but it's no longer in.
The problem there was a fault sharing between the caches, and the caches are constantly thrashing. That's why they're inserted to space them out.
Yeah, right. There's a different issue. CAS on an x86 has a fairly high cost if it's not in your core, in your L1 or L2 for that particular core. One of the things that Azul did in their custom hardware hacks was CAS was much faster if it was competing with other people. That was a major usefulness for hot locks kind of things. After that, you stripe the memory, you stripe the lock on different cache lines, and that's padding, and that's your 12 doubles.
On the hardware side, since I brought up the DDR5 thing, I forget which spec it's supposed to come into, but they're actually moving some of these operations down into the DIMMs themselves. So CAS, for example, I expect to show up probably in DDR7 or something.
That's a good place for it.
So in other words, instead of relying on a particular socket and a particular core on that socket to manage the what is it, Maurice or whatever, the cache coherency protocol and etc., you dump it off onto the DIMM itself.
The only question I have is the cost model, if it's going to be successful. Like on a JVM, you have lots of frequent locking there where no one's competing at all. The cache line sits hot in your L1. The CAS is now optimized to be hot. If it's hot in your L1, it's a couple clock cycles. It's really fast. As soon as it's not in your L1 doing the work, what's the latency to know that you acquired the lock? It's however long memory sends back. Yes, the CAS was successful, and that's got to be cheap under the current programming models.
But for backwards compatibility, I think you'll still have that behavior. So it would only dump it off to the subsystem if it's already contended.
Okay, maybe. The other one going around.
I'm guessing. I'm not a hardware.
Yeah. So. The other thing going around is there are a lot of performance counters where I don't care for the result at all. I just want an atomic add. Don't tell me the answer. I'm not looking at it. Just do an atomic add. And there, the fucking memory can take all the time at once. As long as it's atomic about it, I don't care. Yeah, that would be a good use for that one.
Yeah, that's what we call a blind adjust.
Yeah. Yeah, so I think we were around to like, I want escape analysis to work. It's not, so I'm doing object pooling manually. That sucks. And the JavaScript array, that's it. The JavaScript array, the big array doesn't work because I can't type the memory in Java other than using a new. So like in arenas in C, I type it in C++, I type it because I do an operator new, I do a chunk of memory, I do a cast on it. It's now that type. I've used it at the type. I'm all happy. At the end of my compiler pass, I reset my arena, problem solved. In the land of Java, the only way to type memory is a new operator. I can't reset and reuse it. So each individual object class gets its own pool that I pull from. And that's where it becomes annoying in the land of Java. I have 27 objects I'm doing the pooling hack on. I got 27 pools with 27 types and 27, blah, 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 blah. And there's a lot of boilerplate there.
Well, and the other thing is that Java didn't have a means of folding in an object as a value inside another.
Oh, there's no object inlining. Yeah.
Right.
Yeah.
And you lose a lot. No, you lose a lot on that.
How much would introducing something like slices help this problem to say, okay, I'm just going to allocate a big array, and then I'm going to have some other object that says I have one pointer to the base of the array, and I have an offset of so many objects into the array?
That's not the problem. The problem is I can't type memory in Java without saying new, which also allocates. So I'm going to walk this array of bytes. I'm reading a log file. I'm going to walk this array of bytes. I'm going to inflate the bytes into Java strings so I can do string things, and I can look for certain kind of strings, and I can do pattern match, I can do hash table looks up, blah, blah, blah. Then I'm done with a line of a log file, a terabyte log file, to go to the next line. And all the things I did in that line, I throw away and I grab a new line. Okay, every time I made a string, I couldn't pull it from a pool that reset for every line in the log file. I had to make a new string, which allocates fresh memory that's never been in my CPU cache since the last GC cycle. And that's the memory bandwidth we just talked about. You run out of memory bandwidth because you're endlessly doing new. So you can't do a new string under this model and get your performance. You have to pull from the object pool a string-like thing that has a string API, but the memory comes from a recycle pile that you had before or something. You have to do some hack here. And I've totally done the hacks, and they're ugly. And like I said, performance is tremendous, so it's worth it. But there's no support in the language for it. And you can't use an array that you're resetting, because you can't say, give me a new string where the data is pulled from this array. That's not. So, but by the way, actually, you're really close now that I've said that. What I am doing is saying I have a network byte buffer. I have a string-like thing that backs over it. So when I say, give me a new string, I say, actually what I do is I say, recycle the stir object, it's not a string, and he's backing bytes just pulling into the network byte buffer, or the OS managed direct byte buffer. Then I do string-like things with him, and then I take that stir object and I reset him for the next, part of the byte buffer for the next line. That's what I'm doing with it when I'm managing the memory. So he never makes string objects stirs or only backed over network byte buffers, and I recycle the stir objects themselves. It's an ugly thing and fast. And wouldn't it be nicer if instead I could have Java say, I had a string-like thing, it uses this backing, okay, at the end of my loop, free the string and then make a new string, and it just, if you're in the land of C++, you use DL malloc, the free, that's exactly what it does under the hood. I freed it, I malloced it, I recycled the same memory in your L1 cache. And that's the performance difference, or one of the giant ones between Java and C.
Would named heaps solve this problem?
What's a named heap?
Basically, an arena. I'm going to say, give me 64 megabytes of memory that has this name. And then when I call new, I'm going to pass in the name and say, new this thing, but throw it into this particular blob, and it can make references within itself, but it can't have any outgoing references.
Okay, and then there's a way to say force a GC on the blob, or I make the blob small. You said 64 megs. No, I wouldn't even be 64K, it'd be 2K, 4K.
Right, and you want to have either the ability for that thing to GC within itself if there becomes pressure,
Yeah.
or the ability to just call clear and it says, great, I'll just move the
So,
pointer
but
back to the top.
here's the challenge though. If you want it to GC by itself, nothing can point into it, right? So it's like that's why we broke stuff up into services in our design, right? Because we wanted all the proxies into a heap or whatever the data structure will be, slab.
Right.
We wanted all the extern references to be managed, known.
Yes,
explicitly.
managed. Yes. The problem, right, in the land of a Java, there's no typing on those types to say they point into or out of any particular memory management area. So
Right. When you look
can't
at the way garbage
force it.
collectors work, they try to add that, like that old train thing. They tried to add little metadata bits to link different cars together and whatnot. So yeah.
Yeah.
So what happens if I add a trampoline to that and I say, okay, inside this arena is its own world. If anyone wants to point into the arena, they have to add an entry into the trampoline that says I point in. If anyone wants to point out from the arena, they have to add something to the trampoline that says point out. And you always have to redirect through the trampoline, which makes it slow to reference inside from outside.
So
but the inside can now be cleaned cheaply, because when the garbage collector hits the arena, all it has to look at is the trampoline and say, here's my list of ingoing references, here's my list of outgoing references. Whatever's going inside that mess is itself.
Yeah.
That's what we did.
Classic, right. And what you describe is what normally large garbage collection systems do with generations. They have a what do they call it? Damn it, what's the name for the cross-generation references? Well, there's definitely a list of those kept.
Right, and most of the time you're going to let the garbage collector do the generations automatically. A, B, long-lived.
Right. Right. And
I thought here is you might want to create a specific, essentially, generation or cluster or chunk of garbage collection. And you did give a name.
And the key here is that if I, without any language support to split the heaps up or tell me that how the heaps are split, I will accidentally have pointers go the wrong way, and that will blow the invariant that's needed for an efficient version. So I want the language to tell me, here you're making a pointer go the wrong way. Are you sure you want to do that? And then typically I don't, and I made a mistake and I would correct my code. And then I get a language support that says, here I have an arena for which the rules apply, and I can now do internal garbage collection once every loop cycle or whatever. It's really cheap, it's really fast, it's all good. I don't actually want to do, by the way, a real garbage collection there, because I still have to look at all the live values on the stack, even if it's a stack local guy. Whereas once per trip through the loop, I know there are no pointers left. And I just want the compiler to tell me, I have proven that there are no pointers left because we've cleaned out all the errors because you manually put them in. You asked for that proof. I gave you the proof. Now the reset is exactly flip the bit to the start of the allocation, go again. Right. So there is a set where there is a domain of programs where I want to have a hard proof, nothing leaks, and the compiler helps me get that proof right, and then he can do the fast, efficient thing.
And you ask for that proof at the new?
No, you ask for the proof over some scope that you're going to do some work at. Within this scope, all the news or some set of news, maybe you're correct, maybe I have to annotate the news, go into this arena. At the end of some scope effect, I know that there are no more uses of that arena. All my local variables are disappearing as the scope goes. There are no more pointers into that arena. I can reset the arena and reuse it.
The three cases that come to mind to me is I have a game that's got a frame, and I've got a bunch of frame objects, and I can declare this is a frame object and it should never survive the frame.
Yeah.
And then an analogous thing for a web server where I say this is a request scoped object, and when the request goes away, everything that I allocated to the request should go away.
There are a bunch of
And the third one is I've got a pipeline, and each thing that I'm processing in my pipeline is its own scope.
Yeah, there are a lot of use cases where you'd love to have language supports. This is what Cameron's doing with services. The language support is saying there is a box where I can allocate, do things, but nothing gets into the box unless I'm very careful about how I get in or out. And as soon as I prove that there's nothing going into the box, when I'm done with the box, the reset's like free, and I can reuse the box again.
So here's the big question though, like moving beyond kind of simple statistics gathering and whatnot. Has anyone applied ML to dynamic runtime recompilation?
Yes. You're talking about machine learning when you say ML as opposed to
Yeah,
standard
yeah,
model.
yeah.
Yeah. I've met guys at Twitter who are doing ML on JVM compiler flags. They are randomly, stochastically fucking with flags, looking at performance, and then using ML to drive CI inline scopes and scales and compile thresholds and this and that. I would have not said this was a useful way to go. Fine.
But could you turn it into a,
I didn't-
runtime profiling?
I had that information all internally, and that was the thing that got me on that. This was an answer came up with some set of guys who knew ML but didn't know compilers. And so they're basically applying a generic solution technology into a well understood domain. And if they could go hack the JVM and get that raw data out, they could get a much better answer out, much cheaper. Fine.
That's
Yeah.
only proof that the JVM has too many flags.
Yeah, right. What it amounts to. Now, the internal JVM flags themselves have been set through a long, arduous process that kind of looks like you could do it with ML. Like there's a lot of samples collected over many runs of a JVM that are
That was
tuned.
my main point. That was from the previous conversation, that there are too many flags because over the years there are too many features, this feature and that feature. We don't want it to run every time, so we put it behind a flag and you turn it on when you want to, and you have the use case for it, and that turns into hundreds of flags, and that turns into 1,000 flags, and basically the flags become unusable because the JVM is the universal soldier. It can do anything. We have flags for anything. It knows anything. You have to know just to turn it on. You have to know which flags turn on.
Yeah. Well, the other piece, of course, is you can't mutate the JVM easily now without whacking the flags. And so you have to know which flags it's kind of okay to change what they do, and which flags that you have to leave them in because too many people care.
What is the
XMX,
chance?
XMS do not make sense
What is
in
the
certain JVMs and certain GC. Sorry.
So what is the chance of building AA in a subsumption architecture where the primary evaluator functions, but maybe
I don't know what a
other
subsumption
features are
architecture
not?
is.
So it would be where there is a first principle that must proceed before the second principle and the third principle. And you can demonstrate the functionality of the language with the first principle without implementing second and third. And, sort of,
Give me a
you
concrete
can,
example here.
Yeah, so just building the expression parser and getting a functional result as a proof of the expression parser without yet a memory model or a collector, for instance.
Right.
As a starting point.
Well, that's where I'm at right now. I don't have figured out how I want to do memory management other than I would love to have a Rust and a garbage collector folded together in an efficient way that, as Cameron points out, don't like, the link match should go in the doc. That don't make the language look but ugly because they conflict. Right, the whole point of having a GC is here. I don't care; it'd be easy. And the whole point, as far as I'm sort of manual memory management, is here. I need to be fast, and the easy answer isn't working it for me, so I'm going to force it. Okay, so that's an unknown open question. Do I have an expression parser? Yes, I do.
Well, here's something that did it wrong. Kotlin multi-platform. When you decide to go beyond one model of programming, you have to write every possible emitter as a separate code base with a common section. And
You're talking about
some of these models don't, jive. You have a JVM, or you have JavaScript, no threads, no, express concurrency. You have native, they use a frozen memory model. I think they're getting away from that, but that's 1.5. And the JVM has nothing similar in common with JVM or native.
I'm not
so,
sure. Wait, back up. What do you mean JVM has nothing in common with native?
It's nothing in common with the native Kotlin environment.
Oh,
The JDK is not there. The
yeah,
compilation assumptions are absolutely different. The memory model bears no resemblance. And, you know, again, with Android, it's sort of halfway there, half native.
You know,
with
the whole
JVM.
premise of Java was write once, run anywhere, and it got as close as anybody ever did. But it was a giant ass pile of work, and not necessarily, you know, a useful way to spend your life.
Sun Microsystems had a beautiful vision that Oracle had a slightly different opinion of.
Yeah, Oracle's opinion was, holy shit, this Java thing's everywhere. Surely we can make some money off of it. And Sun's opinion was, let's make a language that can run anywhere. But that didn't make any money, so, you know.
So the challenge with the old Java is that nothing was optional, right?
Yeah.
So it's like, it's like, okay, what do you put in your core, not your class library, but the core of the core of the core of the class library? And the answer is, oh, AWT and swing and you know, like,
right. A million bytecodes, literally a million bytecodes run before you run main. It's like unreal. You start up all kind of logging utilities. You start up all kinds of reference thingies.
It's like I tell people, the fact that it works at all is like one of the most amazing things in the history of humanity. Like,
yeah, it's ludicrous. I was there. I watched the whole thing go. It's like, holy shit, guys, what the hell are you doing? No,
and it goes like, I mean, it starts up in almost no time. It runs like the dickens.
Oh, it's like, gone back and forth on the how fast it started up. There was a lot of complaints about the, you know, I'm initializing whatever 200 independent 300 classes before main. It's like, oh,
let's load all the Unicode data.
Yeah, Unicode. There you go.
Every character in ancient Bangladeshi. You know, it's like, cool, but like
to some extent, that makes me want more stages in my applications. If I can have some way to say, okay, main is where the program seems to start. And start is the thing that runs before main, but needs to run every time because it's doing something like picking random numbers that for security reasons must be random.
So,
and then everything before that, you want to be able to happen in an ahead of time compile. So why don't we write programs where I say, this is my build function and this is my start function, and then I'll call main?
Some things can't be added to an architecture, right? And, you know, scalability, for example, cannot be added to an architecture. Like, it's either there or it's not. Security cannot be added. Security is not something you add. It's something you design before you add the first thing, right? And you know, I think this is just another example of one of those things you can't add. Like, it needs to be architected in.
Yeah, the Java added it and it shows.
So modularity basically has, you know, apologies to Mark, but modularity is not something you can add to a language in runtime.
So where is the place for modularity?
Oh, ahead of the language design. It's during the language design. Like, what do I do with modularity? Oh, here's Jim back again. What do I do with modularity for AA? What am I doing? Well, I have a theory, so no practice on it, but I'm thinking about it now. What does it mean to be modular? What does it mean to have separate compilation? What does it mean to, I want to have private internal guts. That's my secret, you know, keys that Aaron's talking about, having to get security up front. They need to be private. You can't reflect on them. They have to be there, but there's some state, but no one else can look at it except your own self. Yada yada.
Okay.
You're thinking about it now.
The two main roads for modularity, there, of course, there are many, but inheritance or composition, the object-oriented way to design a modular code, or a composition one, which pros and cons.
Well, do I have to have them separate? Must I pick? Does it make sense to blend, or does that turn into a mishmash and I'd rather have picked?
I don't think of those two as being the basis for modularity. I wouldn't introduce either inheritance or composition as a modularity
I
concept.
think something like
how would you
profiles in
approach it?
Ada. I think something like profiles in Ada are an example. You can, for instance, use Raven style profile for real-time Ada application, which disables heap allocation language constructs. So you can literally slice the language features that you want and only select a profile of those features. And this profile has to be designed so it is a coherent whole. But this is what I would say is a language modularity example.
Matt, you're still very loud, by the way.
Still, oh, thank you. How about now?
Yeah. Somehow
Thank you.
you get excited and you lean into the mic.
Is this automatic volume adjustment? I don't know how to turn it off in Zoom, but if anyone does,
It's Chrome. It's Chrome automatic volume adjustment.
I mean, I'm using
It's
the Zoom application. I'm not using
yeah,
web
but
browser.
that's it.
It's web browser.
Oh.
Or you
Oh no, yeah, it's Zoom. It's Zoom then.
Well, it'll be under the
So do
Cameron,
we
what?
need more than closures to give us the modularity? Like to some extent, you can be like,
Hang on a
closures are how I
second.
make classes,
Hang
and
on a second.
closures.
for Matt, under my Zoom meeting, I have a mute button. It has a little arrow next to the mute button, a little upwards arrow. If it's on the main screen, not on the participant list. If I click it, it leaves me a bunch of options on how to pick my microphone, and there's an audio settings, which I assume leads you to fiddling with your volume control.
There's a checkbox that you can uncheck automatically adjust microphone volume, and that might help.
All right.
okay? It's off now. Thank you.
And you sound pretty good, actually. So that's good.
That's how it works.
All right, Aaron. Sorry to stomp you there. Go for it.
Most of the languages I've used have classes and closures and packages, all as modularity primitives. I wonder if we could use just closures.
Oh, that's
like if the only thing that my import does is eval a file and hand me back the closure that file returns when you eval it.
Okay, that was the land of JavaScript for many years, and people kept adding module systems until there were 3 fairly popular, mutually incompatible, well-known module systems before a standards committee said quit that. But they're all backwards incompatible forever and a day now.
Right, but I feel like the reason we needed that wasn't that closures were not acceptable for modularity, but that there wasn't a good import statement. I want an import that is in the standard library, and it loads the files off wherever it gets the files from, and it calls eval, and it hands me back the closure.
So that's Python, I think, is what you're describing.
Yeah.
Yeah, Python, basically, I give it a string, it finds the thing from the string, and hands me back the eval of what that code was, with some protections to prevent cyclic imports.
The problem is, yeah, you can hand a string in code eval, but you have to somehow to this code to be there. You have to write your code, to write your functions in knowing that the code is there, but the string doesn't give you that.
And this is where languages can go in every possible direction, because you look at, like we've talked about Java before, it's the, I call it the stumble upon modularity, right? It's like, oh, you're asking for something I haven't heard of before. Hang on, I'll be right back. I got to check my disk, see if I can find something. And then you've got, like you're describing with Python, the evaluation.
That's very similar. The other thing is build systems love to have a way to get at all the modules, all of them, so they can look at things ahead of time. Whereas the whole point of eval is that you get it late in life.
So
and now you have this
and I would
between ahead of time.
I would heavily discriminate on that though, and say that build systems want a repository. And so repositories are ideal for using with modular languages, but the two are kind of different. I don't want to use the word orthogonal because
right. If I identify all of my code with a string, then my import just needs to have some way of mapping strings to strings.
And then the problem that you have to have types in order to rely on that code. In order,
Well, the other,
so if anything is string to string, you don't know what the type is. You cannot structure a program like, let's say, an interface. You have to have a types. Be it that they are interfaces that they are implemented or not, but you have to have something you can hold on. That something may be resolved later, but you have to structure a program according to something.
so the other thing, Tidor, is that import has two different meanings and they sometimes get conflated. So I'd split those apart too, just like we split modularity and repository. I would say let's split import into two concepts. One is Unix mount and the other is Unix alias, right? So in other words, there's some module out there I want to drag in and mount in my, I'm going to use the generic word namespace.
Yeah,
so
your
that's
namespace,
a
yeah.
mounting.
Yeah.
And the other is that I have a complicated namespace and there's a name that I use too many characters to type. So I want to alias, right? So I want to mount and then I want to alias.
Yeah,
And
yeah.
kind
So
of
like
two
using or as?
Yeah, you're using or as. Yeah, that's a different. Yeah, that's a very different, and that's a simpler thing. That's just a name change, which I'm all good with.
Right.
The key
But
item.
well, the
is,
one builds on the other. So
well, okay, fine. The key for me is that the mount step, it imports somehow the types. Now, one of the ways to import the types is I took text from a file and I parsed it like a C++ pound include header. I'm just saying that's totally there, right? There's another version.
I would classify mount. Go ahead.
There's another version of that which says, like in the land of Java, the import could have sucked in the text, but instead it took a .class file, which is pre-cooked, and read in the types that way. But somehow I got the types in so that the current file I'm in that I'm importing into can use the imported types in a type safe way and carry on. So there's some way to get types in there. And I saw your barf when I said, and you can just parse the text, which is probably not actually very modular or efficient, but God knows C does it. But
right, and the challenge with Java is that the modularity was then at the class level as opposed to, for sake of using the word again, the module level. So,
well, okay, so that brings up another hierarchy level, which is I have something that's like a project level, or a module, whatever you can call module level. I have a class, and then I have local scopes. Does it make sense to have that three-way breakdown? Should it be a four-way? Should it be a two-way? Why is 3 better than 2 or 4?
well, I would argue that a module is something that you would put into a repository. So a module could be as small as a class, but it could be as large as for Windows sake, DLL or Unix SO, right?
When you say module, you mean that in the like version control sense?
Yeah, it becomes version controlled then. Yeah, it's for external publication. In my opinion, a module means it's for external publication. Somebody else is using it, therefore its lifetime has to be managed and versioned. I can't shoot somebody else in the face every time I change this module because it breaks too much shit.
And I like the fact that you brought versioning into it, because I would say that the only thing that has a version is a module.
Yeah, that's fair.
Okay, so you would say the justification of having a separate scope that is a closure from one that is a package is that packages are versioned and closures are not.
Well, I was using modules instead of package, but we can say package. Yeah, the versioned, yeah.
I'm tempted to classify a module with something like names with types. It can be a function, can be a class, it can be a closure, it can be anything.
Yeah.
A name and a type is sufficient to work with it.
It has some.
Well, I think Java did kind of an early version of modules with the jar concept. The jar is basically a module.
Yeah.
And it got used as a module, and I think that's really what they based the module design on, was that utility.
Yeah.
So Java 9 modules or whatever it was.
Yeah. Yeah, right. No, I think that's fair. So a module would be something that could be a closure and anything with types and a version, and is expected to be thrown into a repository.
I think one crucial thing is that you have like the that you separate the where you get a module from and which version from the way you use it in code. So there are some newer languages where like the import statements are basically URLs to some GitHub repository and a hash. And yeah, if you want to like upgrade, you have to do a search and replace throughout the whole code base. And I think that's like not the level of elegance I prefer. So I think it's like it's
That
nice
was
to
so
have like
nice.
it's nice to have like a list that declares, okay, I'm using this module from this repository with this version. And in that sense, Maven gets a lot of things
The
right in that regard.
I'm back and
Cargo has similar, and it's better, I believe, than Maven. Has similar concept. You have a file that you declare your versions, and you use them from there. If you want to change it, you just change this file, this version.
And then as
Yeah,
soon as you have a file, then you have the nesting problem, and now you have many files.
and I think the problem with the way Rust does it is that they simply don't have namespaces, and that's kind of crazy to have like this global thing, and if a name's taken, you're out of luck. Which, as personally,
The Twitter approach to
I
module
think
management.
But isn't this like solved in Maven because my
yeah,
module
it's
is
it's solved in Maven.
tom.cliffc.org and cliffc is the unique identifier.
Yeah, and Rust broke that again, so it's kind of a step backward. So it's
they walked back away from that.
yeah, if you have like a global namespace, so if you decide your module is called ABC, nobody else can have that name.
Oh well, the race is on. You should immediately
It's
publish
like
as
the
many
Twitter.
modules as you
It's the
can.
Yeah,
Twitter
there
namespace.
You can sell the name. This is like
there are lots of people who like register like 400 names, just let it go through
Land
dictionary
grab,
and just took
register all the English words.
yeah, right.
sure.
Yeah, right.
And
Land grab. and then
it's
sell them.
yeah, and people can't.
Domains, right? We're
Yeah.
race is on.
Yeah, and so basically nobody can have nice names, and people can't even decide whether like that's a problem or not. And personally, I really care about names, and if like there is no good name available for a library, I'm not writing a library, because I really hate this. I'm not sure. I think Ruby invented this where they have like libraries, and all the libraries have like really fancy names, which are super clever and intellectual and everything, but it doesn't tell you anymore what the thing actually
I don't
does.
see what the problem is with that Simon 789.
Yeah, exactly. Yeah, so yeah, and they are very convinced that the Maven approach does not work. So yeah.
Wait, who's convinced the Maven approach doesn't work? I mean,
the Cargo people.
Wow. Okay, fine. I mean, I'm looking at Maven versus Cargo in terms of popularity and packages hosted and all that kind of stuff. And Maven doesn't work. Twitch, reality check. Twitch.
Yeah. I think the arguing is that their team is too small to manage a Jira instance, because obviously you need a Jira instance to manage Maven repositories.
You do?
So
okay.
So don't ask. Because like because like if you want to publish something on Maven Central, you have like create this account on the Sonar type Jira and file an issue so that they open your domain name, and you have to prove you own it, and then you can publish. And that's basically like you could automate all of this. There are like RFCs for it, but they decided, well, it's not going to work. So yeah, that's it.
And what happens when the domain name changes ownership?
Then
the package changes ownership.
Yeah.
Love that. That works really well with Chrome extensions these days.
Oh yeah.
Yeah, like you run one tab suspender extension, and then someone is like, "I'd like to buy that from you for $10,000," and then everybody gets hacked. It's really great.
Yeah. The thing is, it's like it's not that a naming system without namespacing would prevent that. So it's it's an issue, but namespaces makes makes things nicer without making anything worse. And yeah,
Who gets
Yeah, so
cliffc.org
this
when I
is-
die?
This is the big unsolved problem with the internet and everything related to it, which is, you know, there's no trust model and no basis for building a trust model.
Yeah.
So
yeah. I mean,
Oh,
you,
we got
you could.
communication out of it. That was good.
Mm.
I'm talking
I mean,
to you
you could-
now, so that was useful.
I trust you, Cliff.
Boy, you got some learning to do. Mhm. Trust me to do what?
But I feel like trust is always going to follow the sort of two steps. One, can I give a name to the entity that controls this thing? Two, do I have good reason to trust that name?
Welcome to, you know, the wide world of international corporations. Who owns it? Some holding company in Bali.
So international
holding
corporations are actually one of the cleaner things. Like, who owns Twitter? Twitter has shareholders. Who owns Harvard? That's hard.
Harvard, like Harvard owns itself. There's a Harvard, fund something, that got funded long. I assume.
Corporations are people, my friends.
I understand, but they have owners, and then the owner food chain can go far and wide. I don't necessarily agree they ought to be given the whole corporate buy. Never mind. That's legal law thing. Stop.
That's me making fun of you know, a little political thing that happened in what, like 08?
Ugly. All right, what else? We're actually an hour and 45 minutes in.
I have a fun update.
Fire.
The project that I've been alluding to for months and months and months and talking about, like, oh, my interpreter work is finally open source. And you might have already seen it on GitHub or Twitter or whatever, but
Drop a link in the doc.
4
Yeah,
on the
throw a
doc.
link in.
It's already on the doc. It's number 4. And
cool.
I want to clarify that I'm
Congratulations.
speaking as myself only, but here's Sky Bison.
Oh,
So
wait.
it's an
okay.
Sky Bison?
Sky Bison.
And what is this Sky Bison an avatar for?
Wrong video series. Wrong anime series.
What Avatar's
Where
not
is the
actually-
link? The
Who's new to the
link,
US?
does
The
it
link is
into
doc,
the
number
docs?
4.
So give us the 30 seconds of Sky Bison.
So Sky Bison is sort of bigly small talk inspired or strong talk inspired. It's a interpreter. It's got inline caching. It's got a really crappy template JIT that I wrote, and emulates the C API, which I think is the more interesting thing because not a lot of runtimes do that well, and we do it slightly better than others. But like,
Would you say that's the main thing that distinguishes you from PyPy?
well, PyPy is a really advanced optimizing tracing JIT, and I had a 2-month sprint to staple on a template JIT. So I would say these are 2 different classes of project. PyPy's had years and years and years of really smart people working on it.
So you
This
would
was-
say you have not caught them yet.
We have caught them in startup time. So purely based on that, we can win in some benchmarks. But if someone were to, staple on like a nice CFG and some type inference and whatever, I think it could work pretty well.
I tried to talk to Python people into doing an official hotspot style JIT thing, and they were
Could be this.
not. I'm sorry?
It could be this.
It could be. And this was years ago. And I got
Yeah.
a big yawn out of that group. And it's
So
somebody
what?
at some point asked me, and I said, and this is why PyPy is not the next generation Python in beta. It's because the Python community is like, we just use C when we want performance, and we don't
People care more now.
So
I'm sorry?
Max, you could,
As much as
you
I'm
could-
curious what would happen if Facebook decided to add a year of Cliff's time to this project,
There you go.
I think I would rather see AA.
Yeah, I want to see AA too.
Well,
But
why not-
Facebook
why
wants
not-
to throw
why
a year
not
of my
use
time in.
AA as
I'll
the
bill 'em.
back end for Max's project, right? Use AA as the intermediate language.
Maybe.
That was my point exactly. Do you think to make a more widely used like an LLVM framework, for example, to other programming languages to compile to the AIR, for example, in order to use the JIT if
Well,
suppose there is a
Stuart,
JIT?
Right, see where it goes. So I'm intending to do my own code generation because LLVM suffers from the problem of not being intended for a JIT, and it lacks a bunch of things that make it generate suck code in a JIT. I've looked at LLVM's JITted code in Julia, and it sucks compared to what Hotspot does because it doesn't grok online runtime profiles. And all of Arthur's time in the last fucking decade has been trying to get LLVM to eat profiles from Hotspot, which he's been modestly successful at. So I claim, I'm speaking for Arthur badly, so I shouldn't do it. But
it will be a huge
progress.
Huge niche to be able to more languages to compile to the AIR.
Yeah, right. So it would be a way that the question is, can I get a reasonable compilation system going, which has to include profiling, which means you have a runtime as well, as part of the whole, the minimal nut that you eat when you buy into it. When you buy into LLVM, you eat the horrific IR, but you can get over that, and then you get a code generation out, but you don't get any profiles without basically redoing LLVM. Like a bunch of Arthur's time is doing upstream work on LLVM proper to eat profiles. Okay, so I hand you a bigger nut. Includes a code generator, target for the back end, some way to execute code that's outside the compiler, or staged or tiered, some profiling data baked in. Immediately, it's an obvious place to pile in a garbage collector. Oh, I don't want to eat a garbage collector, so there has to be a way to think about chopping that in or out, whatever. That's the bigger nut. That's kind of my goal with AA right now.
You do eventually want to produce a binary that has no Java IP in it.
Oh yeah. So no Java IP is definitely one of them. Let's get it off the Oracle thing. And also ability, I would love to have the ability to go help people doing OS level work, which means there's a way to cut out the JIT and there's a way to cut out the GC as a minimum. And there's probably the actual code generation includes typed assembly.
Yeah, I do want my kernel ahead of time compiled.
Yeah, exactly.
For the most part.
Gotcha.
Granted, there's a bunch of stuff that I would pull out of the kernel, but that's a separate discussion.
Right. I'm not writing kernels, but maybe I could write a tool to help somebody write a kernel. I've written kernels, by the way. Now I've written one a long time ago. But, yeah.
What was that, Max?
We talked about Java Flight Recorder 1 or 2 weeks ago, and just like runtime profiling and exposing that. And look, if you're going to provide a backend with, an optimizing JIT, I would love a way to connect the.
Yeah. I did that 20 years ago. I brought out the profiles in Hotspot out of a HTML port, and you got to surf them with a browser. Azul took that, we stepped it up one layer, and then they immediately put it behind a paywall because it was too exciting and it sucked. I have totally taken that tool and run all kinds of other people's big Java programs. 30 seconds with the actual tool on your JVM would give them 30% speed ups because they just didn't know. It gave you the annotated machine code with the Java types and the hardware performance counters all blended together, and you could see where you failed the inline, you didn't know types. Every possible thing came out.
I want some mechanical sympathy.
There you go. Exactly.
Yeah, sometimes writing programs feels like stumbling around in the dark. Oh, I just slammed my face into something hard. I guess there's a wall there.
Right. Wish I could have seen it. The one thing that I came out of looking at Azul, doing the Azul thing, was we did this giant, the learning for me there, one of the learning, that's a lot of learning. One of the learning for me there was we did this giant simulator. And what came out of it was no one had a tool for telling you what's not in your L1 cache. And yet most of your performance is tied up with code that's running in your L1 or not in your L1. And so we had the simulator tell us what was and what was not in your L1 cache over time on an average statistical basis. And you could discover shit like, oh, I have cache coloring issues. All the caches are sharing the same address bits, all offset by some number of megabytes because I set my stacks up at some megs apart. And I ran out of associativity in my cache. So not all my stacks are in the cache at any point because they're conflicting with each other, fighting each other. So on an 8 core sharing an L2 and an x86, it'd be 8 core sharing an L3. I ran out of associativity and my stacks aren't being cached. Holy fuck, that's a slowdown. How do you fix that? Well, you do page coloring or stack coloring. You add a little offset and everybody's off by a few hundreds of K from each other, and then they don't collide accidentally in the stack anymore, and you get performance back. How did you discover that? You had to look at what was missing in your cache, what was not in your cache. And that's it was a giant performance win or loss to screw that up. So there's some mechanical sympathy is definitely a goal here.
So updates on our end, we added a debugger.
Excellent. Let me have an execution model then.
We now have a debugger, and we also now have a working transactional OODB. So
do your debugger hook to like GDB or to IntelliJ?
no, we built it.
It's a standalone debugger.
Yeah.
This is Ecstasy,
Yes.
and you're hoping to backend it with AA?
No.
Not entirely sure how we're going to backend it yet. So we're getting close to that decision. But the
You were
decision
talking
on record, LLVM on record.
Yeah, let's say you're talking LLVM for the past year, so fine.
Right.
And I'm not close to LLVM, so I wouldn't recommend AA either. Some future AA, yes, not right now.
So
How do you think about the choice between LLVM bytecode versus LLVM API?
So there's not really a difference between the two of those. I mean, other than implementation detail, it's the same. If you're using the API, you're just basically driving the same engine that the assembler that they have will pull if you're writing the assembly, which is the same thing that's being driven if you write the IL, whatever it's called. So it's all really the same data model, just different tool chain. So since we're going to be doing the code generation in Ecstasy, that is we're going to bootstrap the backend compiler in Ecstasy itself. So we will probably, if we go with LLVM, we'll probably be emitting I would guess emit the assembler, not the IL. So just because it's easier, if you've ever done backend code generation, it's a pain in the ass doing binary.
How are you bootstrapping it?
How are we likely to bootstrap it?
Yeah.
They don't have execution either.
So we have execution, but it's a proof of concept interpreter. So it's not intended as a carry forward. So we've basically got to determine whether the tool chain emits the round zero code. So if it's an AOT model, or if we have a bootstrap that contains either an emitter, a dynamic emitter, or an interpreter to roll it forward. So I'm angling. I hate there are benefits to the interpreter model, the one that Cliff's used to with Hotspot, but I'm actually aiming for the simpler runtime model approach of the zero gen code emission. So the unoptimized initial emission, and then recompilation either dynamically or offline based on profile data.
So I can throw some factoids. A dumb C style JIT gets you one level of performance over bytecodes. A GCC label vars can sometimes be up to double that. A hand rolled x86 assembly interpreter might be double again, because you can get the dispatch loop, which is all the cost in interpreters.
Oh, we have one of those. It's a lot of fun.
I'm sorry?
We have one of those. I forgot to mention. It's a lot of fun.
There you go. And then a unrolling stage zero JIT is maybe double again, but you will blow code out the wazoo, which turn into iCache issues all the time. So you have to hard kill it to avoid drowning your iCache and then just rebuild, because it's so cheap to rebuild. But the major hack here in any of these zones is to have a fixed size stack frame, so you can intercall with real JITted code without going through the ridiculous hoops. I can step you through the hoops Hotspot does to deal with variable length interpreter frames intercalling to JITted, but it's a fucking pain in the neck. Just get a fixed size frame for your interpreter so you can intercall into JITted code with a fixed size frame.
When you say fixed, do you mean fixed at compile time or fixed like every frame size is the same?
When I do a lookup, when I'm running some code and I decide I'm about to make a function call and I went into my trampoline and he looks up whether I'm doing an interpreted or a JITted and he decides he's doing a JITted call. So he wants to go from an interpreted frame to a JITted frame. You have blended interpreted JITted frames going around. When you hit the JITted code, his performance would like to be, I got called from JITted code, I'm calling JITted code, I'm passed arguments as if I'm JITted, and I'm going to treat as if I'm getting JITted args. So where do my args come from? So when I jump from an interpreted frame to a JITted frame, I have to preload the arguments from what the interpreter does to what the JIT does. If those stack frames have varying layouts on the interpreter side, I don't know where the arguments land necessarily, so I can't shuffle them conveniently. When I do the reverse operation, I have JITted code, I am middle of JITted code, I have failed, the JITted code is invalid, I need to roll it back, and maybe Cameron's technique is I'll never roll back. If I'm going to support a rollback and go again, so I've done an optimistic transformation, nothing with class loading, Cameron. I've done an optimistic transformation. I've never seen this fail. Oh, I saw the fail. Fuck it. All my code is wrong. I can't keep running the old code. I have to go back and patch my stack. Again, if I have variable size stacks, or I want to ask the question, I'm calling stack, asking the question, how big is this frame? Right. If it's an interpreted frame, how big's the interpreted frame? Well, I go to the interpreter metadata and he does some lookup or something happens, right? And I need to find the frames. I need to patch them to say, don't go here again.
You basically need a template for every, you need a template for every possible frame. And it's not just for every possible frame, but even sub-frame, you can have a different layout within the same frame based on which instruction you're at, because you're going to reuse parts of the stack for different scopes.
The Java interpreter doesn't keep the same things on the stack locations the same. And he doesn't, and he varies the types of the things he has anyhow. So you have to ask the individual bytecodes, what is the verifier's typing for that bytecode to discover where things are laid out. So the intercall between JITted and compiled code gets annoying in the special, because in the fast forward case, the compiler takes the JITted point at the point the interpreter's at, and he makes a custom signature shuffle. And it's not too difficult to get that one to work. It's the unwind case where I have blown out that you end up fucking parsing.
So our RIR has really good levels of information. So at any instruction, we know the entire stack layout and all the compile time provable types at that point. So we don't have to do any of the fancy stuff we did with,
yes, we had to go ask basically ask the verifier what the types was. And the interpreter could even know at the time he's interpreting that some bytecodes were dead and couldn't have a value or wouldn't have a value that was forward-looking used by anybody.
Right. But since it's all computable, basically, given an instruction, we can build a structure that says this is the RTTI of the layout of any given frame at this instruction. So I haven't spent a lot of time though on the one you're describing, which is I'm halfway through a function evaluation and I realize I have to dynamically switch back to a different mode or to a different code path.
Yeah.
The trampoline approach is quite easy because you just build you build multiple entry points to the same code. And so basically each entry point represents a different set of assumptions. And if you fall to the bottom of it, then your layout so far is all native interface in terms of function parameter passing and whatnot. But basically you produce the code to call into the interpreter at that point, passing the structure that says, this is what I'm delivering you. This is what you can assume is on the stack.
I did it a little differently. I had calling conventions and I had a signature cache that mapped calling convention to calling convention, and they were dynamically made as you fell into them. And the generator was straightforward. Take two signatures, do the shuffle, put a snippet of code, put it in the cache. So
when you say shuffle, does that include things like my optimized one was taking an int and my unoptimized one is taking some kind of type dynamic? And
everything that JITted to JITted wanted to see happen was one of your signatures. Everything the interpreter was going to do with that code was a different signature. You had to span that boundary. So a more common thing, we didn't do that one didn't show up, but we did do object creation. I know that this function knows that this escape analysis has worked, and therefore this object was unpacked and is in registers passed into me, not as an object. Well, the interpreter has it as an object. He had to unpack it into registers. That's the signature. The reverse, going back to the interpreter, I had to allocate an object on the stack, pack it, and then jump. So signature mappings could get kind of complicated. They started out really easy. They just literally was doing a C ABI, a Java ABI, an interpreter ABI signature, and a cache that just, and given two signatures, he built two in the cache or did the lookup, fine. And then you had trampolines that were jumped to the signature remapper who finally jumped to the code. And that was how you didn't have a bunch of different entry points. The earlier Java JVM version had two entry points, one where I knew the class was correct and one where I did half of an inline cache check. And the inline cache done completely inline is actually a much better way to go. Don't do it the early hotspot. The later hotspot version and the one in the Zool, inline cache is actually the
What's the early hotspot?
Prior to like 1.5 or 1.5, somewhere around there, I got rid of the, maybe I didn't get rid of it and it might still fucking be there. The Azul version, I got rid of that alternate entry point into JITted code. I want to say it happened back at Oracle too, because it was just so much cleaner. But you had to have an inline cache, which was load, compare, branch to fail in the JITted code. And the earlier Sun version was load the expected, then jump to trampoline, jump to a guy who then did the compare the header, branch to fail, if success, fall in. And the inline cache then was actually load the expected and call to where I hope is a correct, but you did the call. When you got there, the stack already had the calls return on the stack. And if you failed, you had to claim you never made the call. And there were weird corner cases where the garbage collector would come in and stop you arbitrarily and try to crawl your stack. And you already had a function call return address on the stack, but it wasn't validated yet. It was actually incorrect. And the garbage collector had to like sort out all this shit out. So if you never made the call until it was correct, you could always stop and interpret your stack at any point, and you always had a valid correct stack state, which helped the GCs a lot. The earlier versions of Hotspot had these issues where because the stack crawl is complicated on very rare corner cases, you very rarely incorrectly parsed the stack, and then you didn't know you had it wrong. And so you garbage collected the wrong way, and you eventually, you die sometime later. It's horrific. Okay. And then later you would test and decide the test was correctly validating that the stack was fucked up. But now what the hell do I do? Well, you turned on the thread and let it run again. And then you stopped it later and hoped it was now in a place that you could figure out what the hell was going on with the stack. So you had a filter that was mostly, it got eventually asymptotically correct that just said the stack was fucked, I don't know. And then just go again and I'll try again. So it's clean stack, it was an I don't know stack and go again, as opposed to clean stack, broken stack, and I don't know it. And then I was just dead. And then broken stack, and I knew it was broken, so I'd go again. Once I got rid of that particular transition point, I never had a broken stack. And so it was never a game. And that, by the way, turned into, I can now do random stack sampling reliably. Every time I could parse my stack. That was Azul only. I could parse the stack 100%, grab some stack bits, throw them in a ring buffer as profile data, and yada, yada, yada. You didn't fail to parse your own stack. So crucial bit on these transitions, be able to always at any clock cycle unwind and parse that stack and know what things are. So you don't want to know that you don't know, you really want to know what the hell they are. And that's, the handshake, the trade-off, clock cycle by clock cycle. What is the state of the stack at any point? I stopped, I took an OS interrupt, I crawled the stack. What did I see?
Right. Yeah, if you know CSIP, you should be able to predict the structure.
What's a
in each
CSIP?
register? CSIP, sorry, ECS EIP. Code segment instruction pointer. Come on.
Oh,
you've written something.
that, like CS
Yes.
colon IP. Yeah, fine. Now I haven't done CS. I've done segments
who
since
says-
x86.
Who says CS:IP?
No, I use IP.
Yeah.
RPC and IP, but not CS, because I haven't done segmentation registers since the.
Well, it's still used. It's just 0. It's now ECS, right? ECS EIP?
Yeah, extended segment register now. Yeah, no, fine. Oh, no, I don't think I even use extended. I think you use some of them occasionally in like string ops or something. Everyone maps all of them to be the same, so that doesn't matter. You know,
Right.
fine.
Right. SS equals CS equals DS equals ES. Yeah.
Right, and you walk away. Don't bother me now. It's 64 bits. I don't care. I don't need segmentation. Fine.
Well, it's depending on the processor, it's 40 or 48, but yeah.
Yeah, right. Okay, fine. So now we're well past 2 hours. Are we? You know, is this good here?
Yeah.
You get your Max. You get your question at least sorted enough. You got things to look out for when you're doing this game. At least the fun bugs. All right, folks. It was a good meeting. Great fun. Till we meet again.
Yep. Bye.